Yo, what's up guys, and today we're going to be talking about conversions, specifically with decimal. I'm going to be talking about two things today. I'm going to be talking about converting from decimal and converting to decimal, because they use very different algorithms. Converting from decimal turned out to be much easier than I thought. My original idea was to go to the hundreds place and add 100 that many times, go to the tens place and add 10 that many times, and then add the number of ones, but that would take much longer than it needed to. Last video, I talked a little bit about bit shifting, and that basically takes a binary number and shifts all of its bits to the left or to the right. Because binary is a base 2 number system, bit shifting to the left is equivalent to multiplying by 2, and bit shifting to the right is equivalent to dividing by 2. Similarly, if we were to do this with a decimal number, for example 20, if we were to shift its digits to the left one, because decimal is a base 10, this would be equivalent to multiplying by 10. And if we were to shift its digits to the right one, giving us 2, that would be equivalent to dividing by 10. Now what this means is if I want to multiply by a power of 2 in my computer, I don't need to use any multiplication algorithm. I just need to bit shift it up a certain number of times. Well, you guys may be wondering, how does this relate to converting from decimal? Well, we can actually use these bit shifting properties, which multiply by a power of 2, to actually multiply by 10. So how do we do this? Well, for example, let's do 5 times 10, which we know is obviously 50. But we know that we can get 10 from adding 2 and 8. And what do we know about 2 and 8? Well, they are both powers of 2, 2 to the power of 1 and 2 to the power of 3. Well, we can find that we can separate this using the distributive property or whatever you want to call it, and we have 5 times 2 plus 5 times 8. So this means that we can actually multiply by 10 by only using the bit shift operation and the addition operation. So let's do a quick example. Let's say we have the number 1. Well, let's bit shift it to the left or up once, and that gives us 2. And then let's bit shift it to the left 3 times, which gives us 8. And so combining 8 and 2, we get 10. And you can test this with any other binary number, it will multiply by 10. So if I were trying to convert a decimal number to a binary number, I would first go to the first digit, multiply it by 10 once, and then multiply it by 10 a second time. And this will give me that number times 100. Then I go to the tens place, multiply that by 10, and then ones place, don't do anything, just take it down, and the sum of those numbers will give me my result in binary. So now let's talk about converting to decimal. And I decided to use an algorithm called the double dabble algorithm, and it's very simple. The double dabble algorithm takes a normal binary number and converts it to a BCD number, which is basically just a decimal number, but each of its digits are represented by another binary number. A good way to think about the double dabble algorithm is that it's made of two parts, checking and shifting. The shifting is simply using a bit shift left. So when you run a cycle, it multiplies by 2 every single time. Now this method works some of the time, but sometimes it doesn't. Sometimes it doesn't correctly multiply by 2. And what people have found, you can simply add 3 before the shift to correct all of these issues. And I'm just running a brief example here so you guys can kind of see how this would work in action. If you guys want to learn a little bit more about this, go just search up Double Dabble algorithm online. And then Mattbatwings has a video where he shows you guys how to actually build a piece of hardware that can run the Double Dabble algorithm. Once I have the BCD number, then I can just simply convert it to ASCII values and paste it on the screen. So I just showed you guys how I can convert from decimal by multiplying by 10 using a cool trick, and how to convert to decimal by using the Double Dabble algorithm. So with the data registers, the formula registers, and now the conversions, this kind of marks the end of the functional part of my operating system. So far I've coded 929 lines of code, and I am ready to get to the fun stuff. So I'm planning on making a few different games and programs for my computer, and I'm not sure which one I'm going to do next, so I will save the surprise for next video. So stay tuned for that video, and peace.